Hello. Please hit like button and subscribe my channel. Also press bell icon for future video notifications. Thanks.
Massive earthquakes are, fortunately, rare events. But that scarcity of information blinds us in some ways to their risks, especially when it comes to determining the risk for a specific location or structure. We haven't observed most of the possible events that could cause large damage, explained Kevin Milner, a computer scientist and seismology researcher at the Southern California Earthquake Center (SCEC) at the University of Southern California. That's what we're worried about. The traditional way of getting around this lack of data involves digging trenches to learn more about past ruptures, collating information from lots of earthquakes all around the world and creating a statistical model of hazard, or using supercomputers to simulate. However, a new framework for predicting the likelihood and impact of earthquakes over an entire region, developed by a team of researchers associated with SCEC over the past decade, has found a middle ground and perhaps a better way to ascertain risk. A new study led by Milner and Bruce Shaw of Columbia University, published in the Bulletin of the Seismological Society of America in January 2021, presents results from a prototype rate-state earthquake simulator, or RSQ-SIM, that simulates coupled with another code, CyberShake. The framework can calculate the amount of shaking that would occur for each quake. Their results compare well with historical earthquakes and the results of other methods, and display a realistic distribution of earthquake probabilities. According to the developers, the new approach improves the ability to pinpoint how big an earthquake might occur in a given location, allowing building code developers, architects, and structural engineers to design more resilient buildings that can survive earthquakes at a specific site. The computationally intensive research was enabled over several years by government-sponsored supercomputers at the Texas Advanced Computing Center, including Frontera, the most powerful system at any university in the world, Blue Waters at the National Center for Supercomputing Applications. We launch a simulation of hundreds of thousands of years, and just let the code transfer the stress from one fault to another. From these simulations, the framework generated a catalog, a record that an earthquake occurred at a certain place with a certain magnitude and attributes at a given time. The catalog that the SCEC team produced on Frontera and Blue Waters was among the largest ever made, Goulet said. The outputs of RSQ-SIM were then fed into CyberShake that again used computer models of geophysics to predict how much shaking in terms of ground acceleration, or velocity, and duration would occur as a result of The researchers found that the RSQ-SIM framework produces rich, variable earthquakes overall, a sign it is producing reasonable results, while also generating repeatable source and path effects. We are working to better understand these results and to define approaches to verify them. The work is helping to determine the probability of an earthquake occurring along any of California's Support for the project comes from the U.S. Geological Survey, USGS, National Science Foundation, NSF, and the W.M. Keck Foundation. Frontera is NSF's leadership class. Compute time on Frontera was provided through a large-scale community partnership (LSCP) award to SCEC that allows hundreds of U.S. scholars access to the machine to study many aspects of earthquake science. The creation of the catalog required 8 days of continuous computing on Frontera and used more than 3,500 processors in parallel. Simulating the ground shaking at 10 sites across California required a comparable amount of computing on Summit, the second fastest supercomputer in the world. But research results such as these are important in order to move beyond generalized building codes that in some cases may be inadequately representing the risk a region face while in other cases being too conservative. Video www.youtube.com watch v=add gctqsjku feature =emb_logo. Please support my channel to grow by pressing subscribe button and the bell icon. We will notify you technological news. Thank you.